Hello, in this video we're going to discuss particle colliders part 3, types of particle colliders. In this video we're going to discuss in particular the Space Ring Collider. So I've drawn a rough sketch of a Space Ring Collider, and I've put a few additions on there. So as you can see, it is similar to the collider on Earth, the ring collider on Earth, with the exception that it is in space. So there are advantages of having a space ring collider in space. And where you'd place this is in high orbit. That's out past the moon. That's where you'd put it. And the arrangement here is we have our ring collider with the collision point and firing point, and the crew accommodation is right next to it. Well, in close proximity to it. That's where all the work is conducted. But with artificial intelligence, it could be an automatic thing, being controlled remotely. So in addition to the Space Ring Collider, I've added a hybrid plutonium power plant with its heating box having a dual function. So the heating box heats the hybrid plutonium power plant, but it is also used for station keeping. So station keeping thrusters are attached to the heating box and just keep the Space Ring Collider in position. Technically it could fly itself to high orbit from orbit with that heating box, no problem. As well as that, we've got a steam-powered aerospacecraft. So that's another new design that uses the same as the heating box. A hybrid plutonium power plant lasts for 52 trillion zeros and years. Does not involve fission. It involves plutonium encased in cobalt and or barium and heating water, which drives turbines. So it's a self-sustaining unit, that one. The only requirement would be for air to be brought in. So and the steam-powered aerospacecraft uses a similar arrangement to the hybrid plutonium power plant, with the exception that what it does is uses the heating box for propulsion, and all that's added is water within atmosphere. It's clean, there's no radiation if you encase the plutonium and barium. It's not a fission process, it is just something that I've come up with recently. So both the hybrid plutonium power plant and the steam-powered aerospacecraft I came up with recently. So we've got our Space Ring Collider, and you could use that for research into new isotopes in space, which means there'd be more space on Earth. And it would be self-sustaining in that configuration. You get all your electricity from the hybrid plutonium power plant, which also doubles as propulsion, just for station keeping. I am the Archangel Daniel, and I'm from heaven. Hello, in this video we're going to discuss particle colliders, types of particle colliders, part 3. The Space Straight Line Collider. Now in this rough sketch, what we've got is a straight line collider, and we have the collision point at one end and a firing point at another. and powering it, similar to the Space Ring Collider, is a hybrid plutonium power plant. And in a similar arrangement, we have the heating box, which provides heat for the power plant, as well as station keeping thrusters. So this structure could be quite long. It would be over 14 kilometers long, and you could have it arranged for manufacture of isotopes in space. Again, like the Space Ring Collider, this type of collider would sit in high orbit out past the moon. And the heating box would last for 52 trillion zeros and years, and it provides station keeping thrusters and electricity. So that's another configuration for a collider in space, and it's revolutionary in design by having the heating box providing station keeping thrusters and a power plant which runs the entire facility. And the steam powered aerospacecraft also uses a heating box which lasts for 52 trillion zeros and years as well, as that would be plutonium. And as described earlier, with the Space Ring Collider, such an aerospacecraft uses steam for thrust. So that's the types of particle colliders, and this will lead humankind to new technology. So it's a very, very exciting future for everyone. I'm the Archangel Daniel, and I'm from heaven.